Hello. Let's go a little, as I was saying, let's go a little deeper into our quadratics. Now, when we last experienced quadratics, I gave you this, the most basic quadratic equation I could think of, quadratic forms. But I'm going to give you this equation in many different forms, three actually to be precise. I'm going to give you three different forms of quadratics, three different algebraic expressions or algebraic visualizations, representations of a quadratic. The first one we're going to focus on is standard form. Standard form of a quadratic has A, B, and C all as known values, but your y, your x squared, and your x are your variables. Now, you might see stuff like y is equal to x squared minus x plus 7, y is equal to negative 1/5 x squared plus x, y is equal to negative 5 x squared plus 7x minus 10. All acceptable forms of standard equation. I mean, even y equals x squared is standard. If you think about it, there's a 1 for the A, there's a 0 for the B, and there's a 0 for the C. So y equals x squared is just standard form. In this case, our A is 1, our A is negative 1/5, our A is negative 5. Our B is negative 1. Our B is positive 1. For those of you guys who can't see that, there's a little invisible 1 there and a little invisible 1 there. We're just lazy. We don't put it down there. But that says 1x. And over here, the B is 7. Whoops. And lastly, we have our C. Our C, in this case, is 7. Over here, it's plus 0. You don't see it, so you got to add a 0 for it. And over here, it's negative 10. In standard form, our C is our y-intercept. And that is the unique thing about standard form. C, whatever this value is, in this case, our y-intercept, when x is equal to 0, when you don't go any left to right, that is where it goes through the y-axis. Our y-intercept in this case is 7. In this case, it's 0. It'll go through the origin. In this case, it's negative 10. That's our y-intercept. That's what quadratic form will primarily communicate, specifically compared to some of the other forms. However, there's one other bit of information here. The A. In a parabola, that's a graphical representation of a quadratic, or it can be like in a parabola. I'm going to do my best to be a parabola for a second. In a parabola, if you have a positive A, your parabola is positively sloped. Remember, you're reading left to right. You're reading left to right. So when you see that parabola and it finishes going up left to right, that's a positively sloped parabola. So your A would be a positive value. If you see a negatively sloped parabola, your A will be a negative value. If you see a really wide, fat parabola, your A will be some sort of fraction. In this case, maybe like negative 1/5. If you see a wide, sloping positive one, it'll be some positive fraction. Maybe 1/5 or 1/6 or 1/10 or 1/20 or 1/2. If you see a really elongated, stretched parabola like this, it'll be a whole number, maybe 5, maybe 10, maybe 7. A will be some whole number, positive. You see a really narrowly sloped parabola downwards, a will be a negative whole number. Negative 10, negative whatever. So that's standard form. Next up, we have x-intercept form. Now, we might have jumped into these variables and constants without too much explanation. You guys are seeing so many letters coming at you in all these quadratic forms. That's why I like to give you a few examples with each one. Don't let the abstract throw you off. Let me give you a few examples. So an example might be y is equal to x minus 5, x plus 2, or y is equal to negative 2 times x plus 1 times x minus 1, or y is equal to 10 times x minus 3, x minus 2. In all of these different examples, our a, once again, communicates the same thing that it would have communicated in standard form. Our a here is 1. You can't see it. It's in a little invisible 1, but mathematicians are lazy. We understand it's implied that this is being multiplied by 1 because, multiplying something by 1 doesn't change it. So we don't write that, but a in this case is 1, a in this case is negative 2, and a in this case is 10. Positively sloped parabola, negatively sloped parabola, positively sloped parabola. Get information just from looking at the a. All right, next up, let's look at our P and Q. P and Q in this case represent P and Q represent our x-intercepts. So if the previous form was standard form, this is x-intercept form. So when you see these different things, you are automatically given the point, or I guess in this case, the 2 points, where these parabolas intersect the x-axis. Let me visualize this for you. This first equation here, you got your x and your y. This one it's positively sloped, so I know it's gonna be a positively sloped parabola. My x-intercept is at 5. Oh, I guess my x-intercept is at 5 and at negative 2, because this would be x minus q, but in this case q is negative 2, so x minus negative 2, or x plus 2. So my 2 x-intercepts here are 5. Let's call that 5 right there. 5 and negative 2. Negative 2 right there. And we know that it's positively sloped. So it might look something like that. Goes through those 2 points. That's what x-intercept form tells us there. Let's look at the next one. In this case, we have a negative slope. It's a little bit more narrow. Let me graph it over here. So we have a negatively sloped parabola. All right, and let's put in our x-intercept. We got x is negative 1, and x is positive 1. And at both of those points, our parabola will go through it. And our parabola is negative, so maybe it's a little bit steeper, so maybe it looks something like that. Maybe that's our parabola. This last one, x, y, labeled my axes. All right, very steep, very, very steep, but it's positive. It's going to go through 3. Call that 3. And 2. Oh, 1, 2. So 3 and 2. It's very, very steep. So maybe it'll look like, I don't know, something like that. Very, very steep. Okay, you guys get the concept though. These points, the P and the Q, they give us our x-intercepts, the points at which our quadratics intercept the x-axis. The last form you're going to be seeing is our vertex form. Sometimes referred to as HK form, but vertex form is the proper name. Once again, let's look at our A. Our A is going to tell us whether it's a positively or negatively sloped parabola. In all three of these forms, our A tells us the same thing, whether it's going to be negatively or positively sloped, whether it's going to be broadly or more narrowly sloped, or broadly or more narrowly sloped, depending on whether it's negative or positive. Our A tells us the same thing. Our H and K, though, in vertex form, our H and K are our vertex. Remember, our vertex is either that highest or lowest point on a parabola. So something like that, that's our vertex. Something like that, that's our vertex. The vertex points. Once again, I'll give you a few examples. Y is equal to x minus 7 squared plus 2. Y is equal to negative x minus 7 squared minus 2. Y is equal to negative 3 times x plus 2 squared minus 10. All right, what this tells us when it comes to the vertex. Now, first off, let's check out the A's for our examples. A here is positive 1. It's implied, it's not there, but the A is a 1. 1 times this doesn't change it. So the A is 1. In this case, the A is negative 1. In that case, the A is negative 3. So you're going to have a positively sloped parabola, a negatively sloped parabola, and a negatively sloped parabola. For these three examples, as such. Like so. What else does this tell us? Well, remember, our H and our K tell us our vertex. So what is our H here? Our H is 7. That's our X coordinate point. And our K is 2. That's our Y. In this case, once again, 7. But this time it's negative 2, as you guys can see. Negative 2. And lastly, my vertex here is going to be, it has to be negative because it's minus H. If it's plus 2, that means it's a negative minus 2, or negative 2. Negative 2 for H, because it changed this right there. This is a plus instead of the minus that you see there, the minus that you see there. That's a plus 2. And then negative 10. Those are our vertices. I'll just graph a couple of them. Do the top one first. X, Y. This one has a vertex at 7, 2. So 7, 2, something like that. It is positively sloped. So if that's the vertex, 7, 2, it'll look something like that. Let's look at the bottom one now. In this case, let me label my axes first. X, Y. In this case, I got my negative 2, negative 10, something like down there, all the way down there. And it is negatively sloped, and it's particularly steep compared to that one. So maybe it'll look something like this. Something like that. Oh, that doesn't look very So those were the three different forms. I'm going to put them all up on the board now. Ow. You have your standard form for a quadratic. Ax squared plus bx plus c. You have your vertex form. Y is equal to a times x minus p, x minus q. And you have your, oh, that's not vertex form. That's x-intercept. My bad. That's an x-intercept form. And then you have your vertex form right here. Those are the three forms: standard, x-intercept, and vertex. Those three quadratic forms are the ones that we're going to be covering in this chapter. And the A will always tell you whether it's sloped positively or negatively. And if it's a fraction, it's wider. If it's a whole number, especially larger ones, it's narrower and more vertically stretched out. And then each one of these will tell you something separate. In this case, standard form, you'll get the y-intercept. In this case, you'll get the x-intercepts. And in this case, you will get the vertex point. So those are your three your standard, x-intercept, and vertex forms for quadratics, and how and why, or what the different constants do to what information they convey to us about our respective quadratic. We'll call it there. Those are the three forms we'll be hitting in Algebra 2 for now, at least. Trying to think. I think that's all the forms that we cover. Thanks, guys. Appreciate y'all. Hope that was educational. Cheers.